right, so let's do a practice problem. We're going to draw Lewis structures first. So we're going to bond, let's do one we love and we know, H2O. Okay, so I want you to draw your Lewis structure for H2O just like we did last week. Putting your valence electrons around just like normal. You can watch me and do it with me if you want a refresher. Go ahead and start by yourself and then till you get stuck, whatever you want. But I'm going to do this one with you. So remember, H will never go in the middle. We'll start with my O, and he has, I don't have a periodic table right here. Here it is. He is in row 16, so he has 6. 1, 2, 3, 4, 5, 6. Yes, it is. My H's are in row 1, so he has 1, and I have 2. So I'm going to put 1 here, and if you forgot, we connect the lines. We don't circle anymore. So that's H2O. I'm going to let everybody get a chance to get there. That's H2O. Pretty simple, like Drew said. Now we're going to use this to figure out what type of bond H2O is. So each one of these hydrogens is bonded to this oxygen through these lines. And that bond has a name. It's a type of bond. So we're going to use our periodic table of electronegativities to find out. So hydrogen has an electronegativity of 2.1. So next to both hydrogens, I'm going to write 2.1. And for the first week of doing these, yes, you are going to be required to write your electronegativities. Just teaches you how to find them. And then O, I don't have O on mine. Someone tell me, what does O have? Electronegativity. So look at your new table. What is it? 3.5? 3.5. Okay? So under my O, I'm going to write a 3.5. Now, I know we love calculators. I am not a teacher that says, don't use a calculator, you'll never have one in your pocket, because every one of you have a calculator in your pocket, and so do I. So, let's do 3.5 minus 2.1 equals 1.4 and 1.4. So when you subtract each of these numbers, these electronegativities, you get 1.4 and 1.4. One rule: if you get a negative number, you've subtracted wrong. Flip them over. Remember, in subtraction, the big one always has to go on top. Sometimes when we get crazy numbers that are close together, you might make that mistake. Electronegativities are not negative. Or at least, let me rephrase. In this class, they're not negative. So our electronegativity for each bond is 1.4. Let's go back to our scale on our table. Where does 1.4 fall on this scale? Polar, because it's less than 1.7, so it's not quite ionic, but it's higher than 0.5. So water, each of these bonds are polar bonds. Okay? Means nothing to you yet. We're just learning the words. Keep that in mind. So don't, I know some of you may be like, what's a polar bond? You can ask me and I'll tell you, but it is coming in the future. We do everything in chunks because God only knows if we're in school for long, if we're going to get another snow apocalypse. So instead of throwing a whole bunch at you and counting on being able to talk about it tomorrow, I have decided to do everything in small little bites. I appreciate you, Drew. Okay? So that's all you're doing for now. We're just drawing structures and identifying the type of bond. Every bond does not have to be the same. So in water, it was nice. Both are polar. They have the same number. They don't always have to. Okay? So I'm going to erase this one. No one has questions about it. We all, okay. No one stopped me, so I'm going to assume you didn't. My eraser stinks, so it might spread black. So let's do one where they're not the same. I'm breaking stuff. Okay, let's see. Let's do, I don't want to do a giant one, but I want to do one where they're not the same. CH2O. I think that's a thing. Watch us get halfway done and me mess it up. This is what happens when I make up problems. All right, CH2O. So we're going to start with our C. It's in row 14, so it has 4. 1, 2, 3, 4. I'm going to put an O somewhere. 1, 2, 3, 4, 5, 6, because it's in row 16. I'm going to put an H somewhere. It has 1. And I'm going to put an H somewhere. It has 1. Remember the hint I gave you last week? If the H is written next to the C, it's probably bonded to the C. So start there. Now we're going to go ahead and connect our dots because we're good at that. But we have a problem. My carbon doesn't have 8 and my oxygen doesn't have 8. We have these two by themselves. What can we do with those two? Bond them again. So I'm going to get rid of them and draw another line in the middle. Okay? I think we might need to practice, but we're getting pretty good at Lewis dots. So now we're going to take this molecule and find what type of bond each bond is. Okay? So let's start with oxygen. Has an electronegativity of 3.5. So I'm just going to write 3.5. Carbon, I don't have on my table yet, but you guys do. What's carbon? I can't hear you. Thank you. 2 or 3? Okay, just want to check. 2.5. So under my carbon, I'm going to write 2.5. And hydrogen, we did last time, so I already have it written down. It is 2.1. And each hydrogen is the same, so 2.1. So now when we do this, everybody still with me? Know where those numbers came from. Just from the table I gave you, you don't have to memorize them. So now when we do this, we're going to subtract only from what it's bonded to. So oxygen is never bonded to hydrogen. You're never going to subtract those two. Okay? So we're going to take, I don't know if you guys can see. Oh yeah, you can see the calculator. That's good. All right, we're going to take 3.5, our oxygen, and subtract our carbon, which I don't even need a calculator for, but I did. And we get 1. For this bond right here, we get 1. Okay? Now over here, we have 2.5 bonded to 2.1. When we subtract those, we get 0.4. And over here, 2.5 minus 2.1, 0.4 again. Okay? So I'm just going to draw it right here real quick so I don't have to pick up another piece of paper. Ionic, polar, non-polar. So let's start with our oxygen carbon of 1. Where does it fall on this paper, on this chart? Polar. Very good. It's above 0.5, less than 1.7. So this bond, I'm just going to draw an arrow, is polar. Okay? Now what about carbon to hydrogen? They're 0.4. Where does that fall on here? Non-polar. So both of these are non-polar because when you subtract them, you get less than 0.5. So if a question asks you, because we don't really care about each individual bond, we care about molecules. What do you think you're going to call this molecule? Polar or non-polar? And I'm going to give you a hint. Since the two bonds that are non-polar have hydrogen on them, and the one that is polar has oxygen on it, which one, hydrogen or oxygen, has a higher electronegativity? Oxygen. Electronegativity dictates everything with bonding. So since oxygen has the highest electronegativity in this molecule, and it has a polar bond attached to it, do you think we're going to call this molecule polar or non-polar? Polar. Because we always go with the strongest electronegative bond. Does that make sense? So while each individual bond, these two bonded to carbon, these are non-polar bonds. And this right here is a polar bond. We will identify that these two are non-polar, but the entire molecule we will call polar because the oxygen made the polar bond and it has the highest electronegative number. That's a little tricky, but good? Okay, let's stop this recording.